Try this again. All right, so problem number 3. Modern Designs, Inc. purchased a computerized blueprint printer that will assist in the design and display of plans for factory layouts. The cost of the printer was $900,000 with an expected useful life of 4 years. The company can probably sell the printer at the end of the 4 years for $10,000. And it is also expected to last 12,000 hours. It was used 2,400 hours in year 1, 3,600 hours in year 2, 4,800 hours, in year 3, and 1,200 hours in the 4th and final year. So you're to compute depreciation under straight line, units of production, and double declining balance. So we'll start with straight line. Straight line depreciation is taking the original cost of $90,000 and subtracting the residual value of $10,000 in this case. That gives you a depreciable base of $80,000. All right? The original cost minus what you can get salvage value, what you can sell it for after you're done using it, gives you the depreciable base. Dividing that by the useful life, in this case 4 years, gives you $20,000 in depreciation. Straight line. Very simple, straightforward. It's what the vast majority, yes sir.
We get the 80,000?
I subtracted the 10,000 salvage value from the 90,000 cost.
Oh, that's not, it looks like
I'm sorry. Yeah, that's my 90,000. All right? So, units of production. You're going to take the same depreciable base, which in this case was $80,000. Only now you're going to divide it by the number of hours that you expect to use it for. That's going to give you a $6.67 per hour depreciation rate. At that point, you just take year 1, 2, 3, and 4. The number of hours in each of those was 2,400 in year 1, 3,600 in year 2, 4,800 in year 3, and 1,200 in year 4. Multiply that by the $6.67 per hour rate, and you get 16,000. This is depreciation. For the first year, 24,000 for the second year, 32,000, and 8,000.
How'd you get the 16,000 depreciation rate?
Multiplied the $6.67 times 2,400. Oh, divided by 12. 12,000 hours divided into $80,000 depreciable base. Okay? I'm going to do a bunch of these. So. Double declining balance. Double declining balance, you're going to create a table with the year, 1, 2, 3, and 4. You're going to start with the beginning book value. You're going to multiply that by a rate, which we'll talk about in a second. That's going to give you the depreciation. And that leaves you ending book value. Yes, sir.
So what is UOP and what is GDP again?
Units of production, or just production. You can call it just production. So SL is straight line, UOP is units of production, and DDB is double declining balance. And those are the three methods that the problem is asking you to calculate the depreciation on. And that's all the problems I'm doing today are going to be these three methods. And the midterm that I'm going to review starting next Monday and that we're going to take a week from today is going to be on these three methods. Yeah. Traditionally, people have done very well on the third midterm. So
is that what you're hinting?
traditionally, I have no prediction up in advance as to how well this particular crowd of academics is going to do, but I am optimistic based upon historical experience. Sorry about that. Sorry about that. Okay, so beginning book value. Book value is defined as, once again, the original cost, which in this case was $90,000, minus accumulated depreciation, which in year one is 0. So the beginning book value is the full $90,000. This is where it differs from the other two methods. The other two methods, we always used the depreciable base to start our calculation. All right? The rate is double the straight line rate. So this is a 4-year property. So is, as a percentage, what is the straight line rate? 25%. Just take 100%, divide it by the useful life. Double it, 50%. That gives us $45,000 in depreciation, leaving us with $45,000 in book value. So at the end of year one, our book value, the original cost minus now accumulated depreciation, is $45,000. $45,000 then becomes the beginning book value for year two. Multiply it by 50%. You get $22,500, leaving you with $22,500. That becomes the book value at the beginning of year three. Multiply that by 50%. You get $11,250. Leaving you with $11,250. For the fourth and final year, you start the year with a book value of $11,250. However, this is where the residual value comes in. What does the book value need to be at the end of year four? $10,000, because that's the residual values. So under this method, you depreciate it down to what you can sell it for when you're done with it. So the only depreciation that is left is $1,250. That's it. Yes, sir.
Where'd you get the 50%?
Double the straight line rate. So it's a 4-year property. So if you take 100%, divide it by 4, You get 25% as a straight line rate. Double it.
So every rate will be the same except for the fourth year?
Yeah, it's always 50%.
Even in other cases when it's divided by like 4 years?
No,
I gotta say, so are we gonna do one that's like 7 or 8 years or 9 years?
we're going to do one that's 6 next, and it'll be different because you're always taking 100% and dividing it by the useful life. Yes, sir.
But why is it 50% if you're only appreciating 1,000?
Well, this last one, yeah. Good point. It's not 50% for the last year because the last year you're just going to take the difference. Yes. Yes. Quite correct. All right? Everybody understand this so far? Let's do the next problem. Problem number 4. On the same page.
So would it be the simple again?
Double declining balance. All right, Miles Construction Company purchased a new crane for $1,442,000 at the beginning of year 1. It has an estimated residual value of $140,000 with a useful life of 6 years. The crane is expected to last 20,000 hours, and then it tells you year 1 through 6 how many hours it was used. Same type of problem. Only now we've got a cost of $1,442,000. We have a residual value of $140,000. That leaves us a depreciable base of $1,302,000. A useful life of 6 years gives us straight line depreciation of $217,000. Yeah, this is minus to get that. All right?
So is the definition of residual value just the value you can...
Salvage value, yeah, what you can sell it for or haul it off for scrap metal, whatever you can get at the end of when you're done with it.
Is that a percentage? Is that a certain percentage or is it very
What?
residual value?
No, it's all, the problem always tells you. Yeah, so in real life, you always have to make an estimate as to what can I get rid of this particular asset for. Yeah.
Does the 217,000 have a name, like the final numbers?
Yeah, it's depreciation expense. Yeah, sorry. Yeah. Yeah, this is the adjustment that you would make at the end of the year if you were doing it once a year. You'd go to your accountant's worksheet like we did, and you would debit depreciation expense for $217,000, and you would credit accumulated depreciation dash crane for the same amount. So that's the entry you would make on an annual basis. All right? Units of production. We're going to start with the same depreciable base, 1,302,000. Only now we're going to divide it by 20,000 hours. That's going to give us a depreciation rate of $65.10 per hour. The crane was operated $3,600 in year 1, $4,000 in year 2, $5,000 in year 3, $3,000 in year 4, $2,400 in year 5, and lastly, 2,000 hours in the 6th and final year. Multiply each of those years by the $65.10 depreciation rate, you get $234,360, $260,400, $325,500, $195,300, $156,240, and $130,200. The book value at the beginning of year 1 is the full $1,442,000. What's the straight line rate? 16.66667%. So it's 16 2/3%. Double it. 33 1/3. So if you take 1/3 of 1,442,000, you get 480,619. Leaving you with 961,381. What's that book value going to be at the end of year 6? $140,000. Exactly. $961,381 is the book value at the beginning of year 2. 1/3 of that is $320,428. Now we have $640,953. $640,953 times 1/3 is $213,630. Now we're down to $427,323. Yeah, we're always subtracting the current year's depreciation from the beginning book value to get the ending book value. Yes.
Did you ever get below the ending value before you get to
Absolutely. You certainly can. And no matter when that happens, whether it's in year 4, 5, or 6, or even in year 2, you stop. Yes. Good question. In the back, yeah.
How did you get the rate again?
Okay, double the straight line rate. So it's a 6-year useful life. If you take 100% and divide it by 6, you'll get 16.666667. All right? Double that is 33 1/3. Or basically 1/3. Because this is 1/6 because it's a 6-year property. So, yes, sir.
How come we didn't subtract the depreciation from the beginning book value in the last?
I did. I took 640,953 and I subtracted 213,630 to get the 427.
In the last, in problem number 3.
I always did. Yep.
Oh, okay.
I got a video to prove it. No problem. Okay? All right, so the beginning book value is going to be 427,323. 33 and a third once again. Gives us, where am I? 142,427. That's 284,896. 284,896. 33 and a third is 94,956. Now we're down to 189,940. So 189,940. We already know that at the end of year 6, we have to have a book value equal to $140,000, which is the residual value. So that leaves us 49,940 as our 6th and final year's depreciation. Everybody good? Let's do one more, and then we'll do some depletion and sale of assets, and then I'll project one up on the board and have you guys.
So that last rate wasn't a third?
No, because if we took a third of that, that would have been, what, 62,000 something? It'd have been too much. And it would have driven the book value below the 140 grand.
So do you need to write down the rate for that or
No. No. And when you're doing this on a homework, an exam problem, you don't have to write the rate in each one. You got to calculate the rate somewhere on the page so that I know what you're using, and then just start multiplying it out. So, it goes pretty quick. All right? Okay. Problem number 7, it's at the bottom of the next page, and then the top of the page after that. So problem number 7, and it's on 6, 3, 37, and 38. So 437 and 8. Back to a 4-year. Bless you. All right. Champ Manufacturing Company purchased a robot for $360,000 at the beginning of year 1. The robot has a useful life of 4 years and an estimated residual value of $30,000. The robot, which should last for 20,000 hours, was operated, and then it gives you year 1 through 4 hours to use. Okay, so in this case, we had a cost of $360,000 with a residual value of 30. That leaves us 330,000. The useful life, we're back to 4 years, and that provides us 82,500 as our straight line annual depreciation. Go back to our 330,000 depreciable base. 20,000 hours gives us a $16.50 per hour depreciation rate. We have 6,000, 8,000, 4,000, and 2,000 as our annual usage of said robot. Multiply the 6,000 hours that we used it by the $16.50 per hour rate, we get 132. 66. Oops, I'm sorry. Nope, 99. Then 132. I skipped a line. And then 66. And lastly, 33. The book value is the original cost at the beginning of the first year. That's the $360,000 that we purchase price of the robot. At the end of 4 years, it's going to be worth $30,000. 4-year property, what's the straight line rate? 25. 50 is double. 180 for 180. 180. 50% is 90. Leaving you 90. Percent gives you 45, 45, and in the fourth and final year, you have 15,000 left in order to take it down to the residual salvage value. Okay, is there any questions on how to compute based upon straight line, units of production, and double declining balance? All right, let's change gears a little bit. I'm going to do one problem on depletion. It's not going to be on the exam, but it's essentially units of production that you would use for tangible, but this is how you would deplete natural resources. What's that? Yeah, I won't erase it. I'm just going to change the problem number. I'm going to do problem number 5 on page 36. It's similar to this units of production calculation that we did in the middle. Yeah, similar. Only now you're buying land and extracting, in this case, ore. It just says ore. It doesn't say if it's iron ore or gold ore or plutonium ore or what. It's just a ore. All right, everybody good? I can leave that last section over there. I'm not going to use the far right side of the board, so I can leave that up for you. All right, in this case, Cantor Mining Company purchased land containing an estimated 10 million tons of ore for a total cost of $440,000. The land without the ore is estimated to be worth $800,000. They expect that all of the usable ore can be mined in 10 years. They have to construct some buildings costing $400,000 with an estimated useful life of 30 years on the site, and then they had to purchase some equipment costing $480,000 with an estimated useful life of 10 years. Because of the remote location, neither the building or the equipment has any residual value. During the first year of operation, the company mined and sold 800,000 tons of ore. So what the problem is asking is to compute the depletion charge per ton, how much depletion expense would be taken in that first year, and then as an added bonus, they want you to depreciate the building and the equipment under straight line depreciation. Okay, so we have cost of $4,400,000. We have a residual of 800 for $3,600,000 in now depletable base. There is 10 million tons of whatever this ore is estimated to be contained in this section of land. And that gives us a depletion rate of 36 cents per ton. The 3,600,000 depletable base by the estimated number of tons contained. So in the first year, you had 800,000 tons extracted. Multiply that by the 36-cent rate, and you get 288,000 as a depletion expense. So actually the problem is asking for the building to determine the depreciation expense in the same manner as depletion. Okay. If we went through and took the building of 400,000 and divided it by the 10 million tons of ore, we would get a 38 cent. What? I'm sorry, the building was 800,000, not 400,000. Thank you. Yeah, that would give you a 0.8. Multiply that by the 800,000 tons produced, and you get 32,000 for depreciation on the building. For the equipment, it's asking us to do the same calculation plus straight line. So the equipment originally cost us 480,000. If you divide that by the 10 million, you get hold on a second. No. Yep. This. All right. I see what they're doing now. Ignore the building and the equipment. I'm not going to ask you a question like that. What they did was they came up with a rate of how much ore has been taken out of the total 10 million. They extracted 800,000. That's an 8% of the total. So they took 8% of the building and 8% of the equipment as depreciation. Ignore that. I have never, ever seen anybody do that before. All right. The last one I want to show you is the sale of a depreciable asset. And so we'll do this, and then I'll project for the last 10 minutes, 15 minutes of class, I'll project a problem for you guys to start on. So let's do exercise number 14 on page 434. So exercise 14. On this one, Lila Company purchased a computer on January the 2nd, 2011 at a cost of $2,500. It was expected to have a useful life of 5 years and a residual value of $250. Assume that this computer is disposed of on July 1, 2014. Record the depreciation for the half of the year that they used it for 2014 and the disposal, assuming straight line under each of the three separate assumptions. All right? So the first thing you need to do is compute what is the straight line rate. So it was a cost of $2,500 with a residual of $250. That's a depreciable base of $2,250 with a life of 5 years. That gives us 450 depreciation per year for straight line depreciation. 5 years.
So 450 is the depreciation.
So that's the per year depreciation. So how many years did we use this computer? 3.5, because we sold it in July. So if we multiply that by 3.5 years, we get 1,575. So if we had a original cost of 2,500, a accumulated depreciation of 1,575, we have a book value of 1,000. No, 925. Is that right? No. Yeah, 925. Yes. All right, so this is the book value at sale. All right, so it's asking you 3 different scenarios. The first one is, what if we just toss it out in the trash? We just dispose of the computer, which we all want to do sometimes. If we throw it away, then all we're going to do is we're going to debit the accumulated depreciation on computer by the 1,575 that we've accumulated. We're going to then credit the computer by the 2,500 that we paid for it, and the difference of the 925 book value is a loss on disposal of computer.
Is it okay to put loss and disposal computer underneath computer?
Sure. Yeah, I mean, yeah, if you didn't, they're your notes. Yeah, they're your notes. Okay? So what if you sold it for $400 in cash? You would have a debit to cash. You'd have accumulated depreciation again. I'm just going to... And then you'd still have a loss. And then credit the computer. So the cash receipts were $400. You still have accumulated depreciation of $1,575 and an original cost of $2,500. So now your loss is only $525. It just lowers the loss by the amount of the cash received. And then the last scenario is, what if we sold it for cash equaling $1,100? Well, we still have the accumulated depreciation to take care of, and the computer. 1,575 and the 2,500. So if we sell it for more than the book value, is that a good thing or a bad thing? It's a good thing, because now we have a gain on the sale of computer. Of $175.
And that CPU, that on all of them, when it comes to the CPU, you list that on the, as an asset, or?
No, what this is doing is it's wiping out the asset. It's zeroing it out. Because when we bought it, back when we bought it, we debited computer and then credited accounts payable or cash or whatever, however we paid for it. And so now we're just taking it off of the balance sheet. So it would remove it from your property, plant, and equipment section of the classified balance sheet. All right? Does everyone understand this?
Do we need to do this on the exam?
Yeah, I'll give you a scenario, and I'm going to review that Monday, like I always do. Right? Everybody good? I was going to project one, have you do it one more time, but I think that's just beating the proverbial dead horse. So, have a good lunch.